Here we go. The whole reason we spent all that time with holes, asymptotes, discontinuities, and all that fun stuff was so that we can look at limits that involve infinity. So let's just take a look at these two very quickly. It says determine each of the following limits as x goes to 1, it says. Yeah, right up here in the directions, from the left and the right. Okay? So basically, you know, I could write that down if you want, but it'd be something like this. You know, limit as x goes to 1 from the right, and limit as x goes to 1 from the left, because that's what the directions are telling me to do. All right? So each of them should have an answer that deals with that. And I chose some relatively straightforward functions. And as far as I'm concerned, if you want to actually look at them in the graphing calculator, that's fine too. But this one should be easy enough because it's a parent graph. What's been done to that parent graph? Right one, right? Now, could you have known that anyways using those little rules that you've just learned? Once you set the denominator equal to 0? And so it'd be x equals 1, right? So how come y equals 0 is the horizontal? Yeah, the bottom's bigger than the top, right? So do you agree that either way, this is what should have happened, right? Because it's x to the first and then x to the 0 on top. And then do you agree that in general, it's going to look something like this because we know it's a parent graph? Actually, that's pretty good. Right? Are we in agreement that, you know, in general? Now you notice that I actually chose, look the point that I chose. I chose where the asymptote is, right? Had I chose, say, over here, it'd be very easy. Or had I chose right there, it'd be very easy because you just substitute the value in and be done. Can I just substitute 1 in there? No, you can't, right? And so this is what we have to do. We have to take a look. So let's go to the right of 1 and get on the road. So we'll say right there. As I keep going back towards 1, where do I go? Positive infinity or negative? Positive. It's gone. Now, how about instead of getting on the road to the right of 1, I get on the road to the left of 1. Do I go to the same spot? Well, if you get left of 1, I'm over here, right? And you get on the road and you keep coming towards 1. Where am I going? Negative infinity. Okay. Does anybody, I'm hoping you start to remember some of these. This is not technically a parent graph, but it's very close to one. It's very close to that 1 over x parent graph, except the x value is going to get squared. Okay. Or let's just do it the other way and see what we can come up with. To get vertical, wouldn't we set the bottom equal to 0? So you set x minus 1 squared equal to 0. What are you going to do? Square root, right? Housify. X minus 1 equals 0. So it's once again at, why is that? Because do you agree 1 is the only value that I am not allowed to substitute into that bottom? Because it makes the bottom 0. Do any other values do that? How about negative 1? Does negative 1 make the bottom 0? No. Okay. You know, 7 doesn't make it 0. 1's the only one that does. How about the horizontal then? Yeah, y equals 0 again. It's actually worse this time, right? The bottom's even bigger than it was on the last example. Because if I were to multiply that out, it would be x squared, right? And again, let's say you didn't know where it was. I'm hoping once you see this graph, you're like, oh yeah, that makes sense. So here's how I pick my xy table. It's quite simple. I just pick something to the right of the asymptote, so let's try 2. WR with 2. So you substitute 2 in back into that original, and I get, right, because 2 minus 1 is 1, you know, 1 over 1, 1. So 2 comma 1, in agreement? Now, as far as what we're being asked here, we're just going to kind of do that. There we go. And what would be another value then to try? 0? Why 0 a good choice? Yeah, it's the other side of the asymptote, right? And let's face it, 0 is always a good choice, right? 0. So 0 minus 1 in that bottom there is negative 1, but when you square it is a positive 1, so it's 1 over 1 again, which is 1. So in other words, that's going to do something along those lines, correct? Now, does it make sense that both of the y values are positive, seeing we were squaring whatever we put in for x? Because if I put a negative 7 in for x, I'm going to do negative 7 minus 1, right? Negative 8. I'm going to square it, make it positive. It's going to be 1 over what, 64? Okay. Once again, I'm asking you for the limit as x approaches 1 from the right and from the left. So once again, we'll just get on that road. So go to the right of 1, get on the road, and work your way back towards it. Where are we going? Infinity. And how am I going to figure out this other one then? Yeah, I'm going to go to the left, I'm going to get on the road, and I'm going to go. So you go to the left, you get on the road, and go back towards 1. Where's it going? Positive infinity. Okay. Yep, they're both positive. I would be cautioned to say that the limit as x approaches 1 is just infinity, because infinity and infinity doesn't necessarily match. I know you think it does, but be careful. Remember when we did limit as x approaches 1 to the right and left? And if they matched, we would say that the limit as x approaches 1 is just that number. But be careful with infinity. Right? Yeah, it's a little tricky. So how is letter C going to differ from letter A? Aren't they almost the same? Right? Aren't they? What do you mean inverse? Not really inverse. Reflected. There you go. Because is this going to have the same asymptote as A? The one that we have? Is it still going to be at x equals 1? Whoops, hit the wrong one. I've done that a couple times now. Well, apparently it's y equals 0. Why is that? Yeah, the bottom's bigger. Gotta be. And again, the reason is as x gets big, it's going to be negative 1 over something huge, so it's going to be 0, right? And so, obviously, can you do an XY table at this point if you don't know what happens? You could, right? Nothing wrong with that. But I'm hoping you know that all that's going to happen is you're going to take where these are and reflect them over the x-axis. Okay. Oop, they're gone. So this one here is going to be down here. This one's going to be up there. Again, would an XY table tell you that? Yeah. So we'll do it again. Limit as x approaches 1 from the right. Limit as x approaches 1 from the left. The easiest thing to do, get on that road, go to the right, get on the road, come on back. Where are we going? Negative infinity. Now, which answer is that? The top one or the bottom one? Oh, the way I have it written. Top one. Okay, connect yours when you do it. All right. How about from the left? What's going to happen on D? I made it look almost exactly the same as D. See that? Except I threw a negative on it. Yep, I'm going to reflect it. So asymptotes aren't going to move? Nope, not really. And they were both above before, huh? So they'll both be below. Again, there's nothing wrong with using an XY table when you do it. I just like to try and use my other prior knowledges. Okay, so on this one, well, let's go to the, get on the road and come back towards 1, going to negative infinity. So that answer didn't change. But if you get to left, work your way out, negative infinity. Okay. Any questions so far? Now you probably know why we spent so much time talking about asymptotes and all that fun stuff, because imagine if I tried to teach all of that also today on top of what you just learned today. That would have been all sorts of fun. And probably how college is. This is a little different. How is this one different? Okay, it's got a 2 out front. What else is different about this problem? What's that? A little symbol, which is infinity. So its limit as x approaches infinity and x approaches negative infinity. So I'm not approaching 1 anymore, apparently. But I tried to trick you because I kept x plus 1 at the bottom. All right, but where are these asymptotes going to be? Well, set the bottom equal to 0. Do you agree it's x equals negative 1? How about horizontal and or slant? Yeah, it's still 0. Bottom's still bigger. How are you going to figure out where stuff is? Yeah, get it in a little XY table. Figure it out. X, Y. So you said 0 is a good choice? I agree, because it's to the right, and it's a nice, easy number to do. And so what's your answer? Yep, 1/2. So 0, comma 1/2, so we'll say about there. All right. What's probably another good choice? Probably shouldn't use red, huh? Oh well. -2? I agree. -2 is a good choice. Let's just fix that quick. You put -2 in. Right? -1/2, do you agree? So in other words, -2 and something ball, yeah. All right. So limit as x approaches infinity. So as x gets huge, in other words, do you agree if we get on the road over here somewhere and as x gets bigger, I'm heading that way, correct? So here's the important, which y value am I getting closer and closer to, but will never get to out that way? 0, very good. Because that's where the asymptote is. That's really all it's asking, where's the horizontal asymptote? And then limit as x goes to negative infinity. So we get on the road, maybe we'll start right here. Our x values keep getting more and more negative. What y value am I going to get closer and closer to? But way out there, I'm never going to get to it is 0. Now, once again, what if it did cross right here? I'm asking as it gets big. All right, I'm not asking about right there. Okay, I'm asking as it gets big, what's it getting closer and closer to? Okay, letter B. What do you notice? You can factor the denominator most definitely. What do you factor it into? X plus 1 and x, minus 1. Does any of that cancel with the top? No. So are there any holes? Nope. That's kind of nice. How about verticals then? There's 2 of them. Very good. 1 and -1. Yep. Slant? Not overall. It's squared and squared. Yeah, they're the same. So very good. Yes, you look at that fraction then. Right? 1, 1. When they're the same? I wanted to see if you'd remember that. Very good. Y equals 1. And to find out where they go, you can do your XY table. Or I think just to speed things up, I'll just show you where it goes. Does letter B have the same answers as letter A? Limit as x goes to positive infinity and as x goes to negative infinity. Is it the same answer as 0, like we got in letter A? Yeah, basically that's what it's asking. Because this is saying as x gets really big positive or really big negative. So does this problem really care about that? No, it doesn't care at all. It says if you get on that graph, you get on that road and you start going to positive infinity, what y value are you getting closer and closer to? And in this case, it's 1. How about if I go the other way? Isn't it still 1? I think you should try and factor the numerator and denominator. Okay.